Today's lesson is kind of fun. It's the history of astronomy. We're entering our last unit of Earth science, so the finish line is in sight. Astronomy is one of the original sciences. As long as people have looked up at the sky with wonder, they have talked about the stars and the planets. So constellations play an important role in our history. Pictured as the constellation Orion. Orion is the hunter. The lower right image is the tracing of the main stars of Orion. So he's carrying a bow and has a famous belt. So maybe you can visualize that. A lot of times the constellations don't look like what they're depicted to be, but folklore and legend, stories, maybe a soap opera in the sky when you're talking about Perseus and Cassiopeia and Andromeda. The International Astronomical Union recognizes 88 constellations. They are traditionally, the names have been kept, but they're really regions of the sky now. So a lot of the romanticism has been lost. So we map the night sky. The constellations, the alpha stars, the brightest in the constellation, and the beta stars, the second, and you go through the visible stars with the Greek alphabets. Brightness actually depends on both distance and how bright the star actually is. So we have magnitude and absolute magnitude. We have 14 famous constellations that lie on the path of the sun. The path of the sun is called the ecliptic. Those are the signs of the zodiac. There's actually 13. Ophiuchus was omitted, but the signs of the zodiac are merely constellations that lie on the solar plane called the ecliptic. The celestial sphere is how ancients believed the sky was. It was a big dome over us, and it's called the celestial sphere. It was believed that this dome is rotating around Earth, and the universe was geocentric, or the center of the universe. But since we've disproved that, but we still use the celestial sphere to describe the night sky. So Earth rotates 15 degrees per hour. The celestial sphere is a great 180 degrees, so we move 15. Things move 15 degrees an hour. We mentioned our minutes and seconds when we talked about latitude and longitude. Those are just divisions of the degree. The altitude is the height above the horizon in degrees. The zenith is the point directly overhead, and incidentally, the nadir, not listed, is directly below your feet. And then the azimuth is the distance from true north. Just like latitude and longitude, we have declination and right ascension. And stars are mapped with declination and right ascension, which is analogous to latitude and longitude. Being the Earth spins, a time exposure leads to star tracks. These tracks move around Polaris in the northern hemisphere because Polaris is near the celestial North Pole. You can see the true colors of the stars in this time exposure. When you look up with your eyes, they all look white, but you can see that stars definitely have colors, and those are based on their temperature. So right ascension and declination. Right ascension would be like the longitude. It's measured in hour circles because of 15 degrees per hour. And declination measured in degrees north or south of the celestial equator. So this is a map from the North Pole. At the zenith, you have Polaris. Polaris's constellation is Ursa Minor, the little bear. You can see Draco the dragon, Cephas the king, Cassiopeia the queen. You can see Ursa Major, which contains an asterism called the Big Dipper. You can see around the perimeter, you are listed in 22 hours, 21 hours, 20 hours. Right ascension, right ascension. Declination, right through the middle of it, you can see 40, 30, 80, 70, those numbers. That is above the celestial equator. So this is a round map because you're at the North Pole. When you're standing, when you look at the equatorial maps, you see that they're flat. There's a series of 4-star charts, one for the North Pole, one for the South Pole, and one for the Western Hemisphere and one for the Eastern Hemisphere. So these are the constellations. You can see the ecliptic moving through the constellations. The ecliptic is above and then below the celestial equator. The constellations on the ecliptic there's Gemini, the twins, are the zodiac signs. You see the declination, which is analogous to latitude. You can see the right ascension, which is analogous to longitude. You can see the relative size of each star, that is its apparent magnitude, large being the brightest, so Sirius is the brightest star in the night sky. So a lot of information on these star charts. So you read star maps by locating and naming the constellation, naming the alpha and beta star of the constellation, determining the apparent magnitude and the celestial coordinates of stars. Astronomy is rooted from the Stone and Bronze Ages, when human cultures realized the cyclic nature of motions in the sky and how they were tied to the cyclic natures of climate. Monuments, which not only praise the gods found in the sky, but also show calendars, date back to 3000 BC. They were calendars, predictions of eclipses, and monuments to gods and goddesses. Some of the early monuments are simple markers, circles, and temples and tombs. There's a famous Stonehenge, famous circle. Stonehenge is in Great Britain, and it aligns with sunset, sunrise, moonset, summer and winter solstices, and most likely it was a celestial calendar. The Bighorn Medicine Wheel in Wyoming has 28 spokes. These spokes symbolize the days in the lunar month and summer solstice. And Rigel, Aldebaran, and Sirius, bright stars, are tracked. In Mexico, the Chirazal Temple and the Mayan culture have many, many monuments dedicated to gods, goddesses, and they act as observatories and star charts. The Mayan calendar, which was famous, the end of the world, December 21st, 2012, but the Mayan calendar also measures the movements in the night sky. In China, we have ancient Chinese. You see the beautiful instruments on the right. Those wheels are turned and star angles are measured, but they're also art. And one of the oldest observatories is in Beijing, 1442, and then the first eclipse was recorded in China in 2136 BC. Ancient Egypt, the pyramids of Giza are lined up with Orion's belt. Of course, this predates the legend of Orion. During the Bronze Age, planets were known out to Saturn. Now, planets come from the term plankton, Greek for wandering, because planets don't move like the stars. Remember, we're going around the sun and so are the planets, but the stars aren't. So planets, when they're tracked, move backwards, which is called retrograde, and they wander, so planets, plankton, wandering. This wandering motion actually helped to debunk the geocentric model of the universe in the Middle Ages. So Aristotle, very famous for this geocentric model, and his model was accepted until the Renaissance. Euclid, great mathematician who is known for geometry, which means earth measuring, played an important role in astronomy. Aristarchus of Samos was the first to propose a heliocentric or sun-centered solar system. It was very criticized because Aristotle rejected it, but his was based on mathematics, and he calculated the distances to the sun, the moon, the axial tilt very accurately, even though trigonometry still hadn't been discovered, invented, or described. Eratosthenes was the first to measure Earth's circumference using shadow angles. He also was a librarian from the Great Library of Egypt. This library famously burned down and most of human knowledge was lost, leading into the Dark Ages. Been popularized in movies and televisions with the Librarian series, the Ancient Egyptian Library. Hipparchus, who's famous for the Hippocratic Oath, also was a great astronomer, and he categorized star brightness. He also measured the distance to the moon based on eclipses. Ptolemy published a book called the Almagest, which was most influential for almost 1,500 years. There's Ptolemy's universe, and that was accepted through Renaissance times. Ptolemy tried to describe the wandering of planets by what we call retrograde motion. The planets are moving around an imaginary epicycle as they went around the Copernicus is famous for bringing about the heliocentric model. Although it was described in ancient Greece, he was a very famous Polish mathematician. He published a book before his death called De Revolutionibus, and he is credited as one of the great thinkers of the Renaissance era for disproving this geocentric model that was accepted. He was excommunicated and faced execution for releasing this book, but he died before he could face the consequences. We are going around the sun. This is us going around the sun and Mars going around the sun. Here we go. And you can see as we pass Mars, the planet tends to move backwards and then forwards again. So that is what retrograde motion is. Tycho Brahe, famous for many things, including his drunken behavior, sword fights, and his eventual controversial death, which many say is because his bladder ruptured when he was drinking with the king, and he was holding back, having to go to the bathroom because the king, you're not allowed to leave the king's presence until dismissed. But it was also shown that he had high levels of mercury because the aristocracy back then snuffed mercury, which was to help combat colds. But mercury causes brain and bone damage, so, However he died, he was famous for also being a diligent measurer, and he measured the movements of planets and has the best observations during the Renaissance period. His Tychonic model of the universe is shown. A lot of moving parts. It's pretty far out. But it did keep the Earth at the center of the solar system and allowed him not to be burned at the stake, which was one of the penalties for blaspheming and saying that something else was the center of the universe. Now, Kepler, who discovered Kepler's laws, was trying to prove geocentric because, the way to get the education back then was to become clergy or be super rich. So most of the education was monitored by the church at the time. So he was trying to prove the geocentric model, but he actually inadvertently proved the heliocentric model, although he never believed it. He discovered planetary motion is elliptical with the sun at one focus. Proved that when you are closer to the sun, perihelion, you move faster, and when you're further from the sun, aphelion, you move slower. And he measured how fast a planet moved around the sun based on its distance. So Kepler's laws were very important in showing that the sun was the center of the solar system and Earth was not the center of the universe. Now, during the Renaissance, the first to consider stars are other suns was Bruno. He was burned at the stake for heresy because of teaching this. Galileo was not just a poor boy from a poor family, but he was the father of the scientific method, one of the fathers of the scientific method. He got in a lot of trouble with the church. He was sentenced to house arrest, excommunicated, but he was friends with the Pope, so they allowed him to live there. He was going blind from looking at the sun through a telescope and suffering from a lot of ill health. He was pardoned by Pope John Paul II centuries after his death. He did so much, we could bullet point it, but some of his big things was he's the first to use the telescope. Hans Lippershey invented the lens. Lippershey, when the lens got out, people started like Hooke and von Leeuwenhoek started to build microscopes, and Galileo built a telescope. He discovered sunspots, features on the moon. The moons of Jupiter are called the Galilean moons because he discovered that. That proved that Earth was not the center of all motion. Very controversial. Phases of Venus, Saturn's rings. So he's the pioneer of the scientific method. And here's some of the, there's his telescope, the Galilean moons, and the sunspots, which are things that we talk about in astronomy. His finger is on display in the Natural History of Science Museum in Italy. So that's Galileo's finger. Why? I don't know, but that's just not my thing. Sir Isaac Newton, brilliant calculus, Newtonian physics, also invented the Newtonian telescope, which is used as a reflecting telescope. He also described gravity and the universal constant of gravity. As you can see, there's the formula on how we calculate the force of gravity. Messier, he is famous for cataloging non-comets. He loved comets, so he cataloged everything that wasn't a comet to say, hey, don't bother with this, it's not a comet. Of course, by doing this, he actually was the first to catalog deep space using a telescope, and they're called Messier objects now, things that he probably would cringe because they aren't comets like the Andromeda Galaxy and melogenic clouds and nebula. And things are called Messier objects because he cataloged them as things not to look at. So there's his catalog of space objects, the Messier objects. Sputnik from the Soviet Union was the first artificial satellite, And it kind of set out the Cold War, the space race, creation of NASA, and really motivated America, Soviet, and the world to become what it is today when it comes to astronomy. So NASA did launch in response to Sputnik because we didn't want to be outdone by the Russians. Yuri Gagarin, the first human in space, was another disappointment for America because we wanted to have the first man in space. Alan Shepard was the first American in space a month later, but again, we lost the space race. So close and yet so far. John Glenn, first American to orbit the moon. Later on in life, he became the first senior citizen to go into space. Maybe a publicity stunt. It was said that they wanted to study aging in space. JFK boldly challenged the world or America to put a man on the moon. So he launched this initiative to put a man on the moon in a famous speech at Rice University. We did make it to the moon. This is a picture of the Earth from the moon. Very famous, beautiful picture. So the inspiration was brought on by Kennedy to do something hard, do something difficult, and put a man on the moon. Apollo 1, which kind of kicked off this mission, ended in disaster where the crew were killed in a fire right on the launch pad, never got off the ground. Ed White, famous local hero, was one of the people that died during Apollo 1. Apollo 11 was the first to make the moon. Neil Armstrong was the first to set foot on the moon. Today we use unmanned space probes. Cheaper, safer, sends back data. The Space Shuttle program, which started in 1981, was very famous and ended and no longer is in use. The space shuttles are really amazing, and you should definitely make it across the state to NASA if you have a chance. We do have two disasters in the Space Shuttle program, very famous, the Challenger and the Columbia. The Hubble Space Telescope, which was launched in 1990, gave us our first look without the atmosphere. Amazing, and over 4,000 new discoveries have come about because of this Hubble telescope, named after one of the more famous American astronomers, Charles Hubble. We also have international cooperation at the space station, which has led to improving relations between countries that traditionally haven't got along well. Albert Einstein, famous, and we'll discuss his theory of relativity when we talk about the Big Bang Theory in a future lesson. And we'll wrap things up with Stephen Hawking, who has expanded on Einstein's theories of relativity.